Hi everyone. Okay, let's jump on to another example with some different transformations. So this time we'll be starting with a sine wave. And what I'm seeing, let me grab a pen, is a negative out in front. So that's applied to the entire function. So that's flipping your y values, which means we are flipping or reflecting over the x-axis. So y values flip, which means upside down over the x-axis. And then I noticed that there is an extra 3 in the parentheses that's not in our standard, just sine x. That is inside the function, so that's affecting our x values. And remember, everything affecting x values is backwards. So that's horizontal compression, and that would be by a factor of 1/3. So we're going to cut all of our x's in, that's a weird way to say it. We're going to divide all our x's by 3. Let's say it that way. In terms of trig vocab, okay, let me put some axes in here. I think I have an odd number. We'll just go about like that. Okay, so there's my x and y axes. This is not shifted up or down at all, so my equilibrium will be right on the x-axis. The only thing multiplied by the sign is a -1, so the amplitude will be 1. So let's see, just to make this easier to draw, I'm going to say 1 is up here, -1. So the amplitude is 1. So we have to go up 1 and down 1 to get to the maximums and minimums. And then there's no horizontal shift either, but there is a compression. So if we think about our normal sine wave, looks like this. Goes through 0, 0. That's a great point to follow. And then if needed, you can snag 1 or 2 others to follow. But let's just start with that 0, 0. So I'm going to say, okay, I start with 0, 0. When I flip upside down, that doesn't move. And when I divide my x by 3, it still doesn't move. So this new graph should still go through 0, 0. That potentially, when you get good at this, when you get used to it, is enough info to get me started. I know the negative is going to send me the opposite direction, so I'm going to go down as I head right. But for now, let's follow one more point just to get that idea without feeling quite so hand wavy like I'm doing magic. So let's see, this would be 2 pi and pi. So this is at pi over 2, 1. And we need to flip upside down. So that's going to go to pi over 2 -1. And then we need to horizontally compress by 1/3. So we're going to divide the x by 3 and we'll get pi over 6. And actually, while we're at it, so let's see, pi over 6 -1. Let's figure out what our period is and use that to figure out how far apart our tick marks should be. Sometimes the trickiest part of this is just getting the right tick marks. And if you lay your tick marks out really nicely, it becomes really easy to almost autopilot these. So my period is always going to be 2 pi over b, which in this case is 3. And then the key points on the sine and cosine waves are always a quarter of your period apart. So if we do a quarter of your period, that's going to be 2 pi over 12 divided by 4. So it's 2 pi over 12, which reduces down to pi over 6, which notice how that's lining up with that point I just followed. That's not a coincidence. So we're going to make our tick marks every pi over 6 units. So this is going to be pi over 6 are our grid lines, and then 2 pi over 6, which reduces down to pi over 3. And then 3 pi over 6 is just pi over 2. And then 4 pi over 6, and again, this just takes practice to get good at these, reduces to 2 pi over 3. And then 5 pi over 6, and 6 pi over 6 is pi. So that's pretty good. So what we had to go 1, 2, 3, 4, 5, 6 would give us negative pi. Halfway is negative pi over 2. Okay, that's pretty good labeling. You don't have to label every single one, but definitely enough that I can tell how far apart tick marks or grid lines are. And we just said it goes through pi over 6 -1. And then we know what sine does. It goes from equilibrium to minimum, and then it comes back to equilibrium, which will happen in that same quarter of a period, back up to equilibrium. And then in the next quarter of a period, it'll go up to the maximum. And in the next quarter of a period, it'll come back to equilibrium, and then minimum, and equilibrium, and maximum. And hopefully that doesn't just feel like I'm being magical. And you can see how you can kind of, if you break this up carefully and you're really careful about what your tick marks are and get a really good starting point, it becomes really easy to just follow the wave pattern through. So that, I would say, is a good goal, is to remember to do a quarter of the period and just be very careful about following one point through so that you're starting at the right spot. So this was pi over 6, -1. And then be ready for a quiz or something for me to ask you to label a certain number of points. Maybe I'll say an equilibrium and a max and a min, or just a max and a min, or label at least 4 points. So just make sure you're comfortable following through and getting those other points. Otherwise, that's it. I would like to also really quickly show you how to check these in Desmos. I haven't remade all my trig videos as of when I'm making this, so I don't know how much, if any, Desmos use I've shown, and I want to make sure you see that and know how to get the axes labeled in fractions of pi. So let me switch over. Okay, so we had y equals negative sine 3x. Okay, for starters, I really did just type in sin, and it understands that, and it will understand your other functions as well. But do note that you can pull up this little keyboard at the bottom, and there is a functions option, and there's your trig functions. We'll do inverse trig as well, so those are there. Note, for future reference, there's some really good calculus formatting in here. So if you're ever looking for something, try over here. Okay, and it gave me a graph, and it's decent. It doesn't really match what I gave. One thing I want to show is we're going to play with graph settings. Down here at the bottom, you can choose radians or degrees. So we're, for most of the quarter, just going to stick in radians. When we come back to some right triangles, we'll look at degrees again, but you can choose. And then our x-axis, hold on, let me switch back to our graph and see what I did there. So we were going from negative, so like, oh, I don't know, let's just say negative 3 pi over 2 to 3 pi over 2. It's a little more than what we showed, but close enough. And then our y was like negative 3 to 3. Okay, so we're going to say negative, this is x's, right? Yep, it's 3 pi over 2. And you can just type pi for pi. I don't remember if I've told you that already or not. Oh. 3 pi, and then you just do the slash for division, and then you can label if you want, but what I'm really going for is step. That's your tick marks. So we want ours to be pi over 6, and it really will do that for you. And then y-axis, we want to go negative 3 to 3, and we can say, oh, I guess they were 0.5 is what they really were. And we can take off minor grid lines if you only want to see the grid lines that we said, or you can put them back in. You can hit zoom square if you want something where the x and y scale is actually the same, so it doesn't look, say, taller than it is. For example, 1 on the y-axis here, and this is roughly negative 1.57, is not really to scale. It's looking a little taller than it really is. So if you ever want to get a sense of that a little better, you can absolutely do it. So play around with these. I'm clicking this really quick. Ooh, we don't need logarithmic scales. That's, I think, new. Okay, so there's your graph, and you can check yourself, but you can absolutely get Desmos to do labels for you. It doesn't show every pi over 6 because that's just too small. If you zoomed in, it would. But it will label in fractions of pi for you so that you can check yourself, and then you can just click right on to make sure your maximums are right, your minimums, and your equilibrium. So we need to be able to do this without always using Desmos, but it's a great way to check yourself. Okay, I think that's it for this one. Thanks for watching.